This is lesson 7-2. We've been talking about properties of exponents. Previously in lesson 7-1 we talked about multiplication properties. Now we're going to be focusing on division properties of exponents. So we have a couple to learn in this video, and then there's a second part to this lesson. We'll learn a few more properties. But first, I wanted to go back and just review really quick the exponent rules we've already covered. All right, so we have, let me find the pen. The first thing we learned, we learned like 3 different rules in the last lesson, so I don't know that they're in this order, but 3 of the things we learned were, one of them was, whenever you have multiple factors inside of parentheses and an exponent outside parentheses, you want to distribute that exponent to each factor, right? So this is like saying a to the third times b to the third times c to the third, right? A, B, and C are all being multiplied here. That entire product is being raised to the third power. So then I can just distribute that 3 to each factor and raise them individually to the third power. Okay, the next thing we learn, excuse me, is that when we have, excuse me, when we have an base raised to an exponent, remember an exponent tells us how many times we are going to multiply the base by itself, right? So we're going to take the base, a to the third, and we're going to multiply it out 4 times. So I'm going to have a to the third times a to the third. Now that's twice I'm multiplying it, times a to the third times a to the third. Whatever this number is, that's how many times you're going to write out the base. Okay, and since it's an exponent, it's telling us how many times we're multiplying the base. We're only multiplying it 3 times, but we have 1, 2, 3, 4 bases. So you should write it out, this number, okay? And then, so when we get here, how do we simplify that? Well, we learned this rule. Whenever you multiply bases that are the same, you add their exponents, right? So this is the same as saying a, that's our base, to the 3 plus 4 power, right? Which is a to the 7th power. Okay, so before I go any further, I just wanted to kind of give you a visual on that really quick, between the difference between these two, right? So for this guy, let me go other example over here. If I had a, let's say, to the 5th times a to the 3rd. What does a to the 5th mean? It means I'm multiplying this base out 5 times. I'm writing a 5 times and I'm multiplying them. So I'm going to do that. I'm going to do it in blue for this first one. So I got 1, 2, 3, 4, 5. That's a to the 5th. Times a to the 3rd, which is, I'll do it in green here. 1, 2, 3. So I'm multiplying my base, which is a, out 5 times, okay? So this times this looks like this. Well, how many times am I multiplying a now? 1, 2, 3, 4, 5, 6, 7, 8. So the answer here is a to the 8th power. So essentially, what did I do? I just added up how many times I have the base written out. So I have it written out 5 times here and 3 times here. 5 plus 3 is 8. That's why I add exponents, right? So that's how that works. Okay, so what's the difference when I have a to the 5th power raised to the 3rd power, right? What's the difference between this and this? Well, here, our base is a to the 5th, and we're multiplying it out, we're writing it out 3 times. So I'm gonna write out a to the 5th, a to the 5th, a to the 5th, right? That's my base, and I'm multiplying it out 3 times. So a to the 5th, a to the 5th, a to the 5th. And then, just like we did up here, for this one down here, I can write a 5 times here, a 5 times here, and a 5 times here. So I know you understand that, but just to get a visual, I'm gonna go ahead and do it. So I'm gonna have 1, 2, 3, 4, 5. And then this a to the 5th, 1, 2, 3, 4, 5, times, and I'm going to run out of room here, the last a to the 5th, 1, 2, 3, 4, 5. So how many times am I multiplying out a here? A to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? So here, when I have a base with an exponent raised to another exponent, instead of doing all that work, my shortcut is I just multiply these two exponents. 5 times 3 is 15. So hopefully you guys see the difference here. Concept is the same in both. The exponent tells you how many times to multiply the base. Here, the base is just a. Here, the base is a to the 5th. So the number of times we write out a changes a lot. Okay, hopefully that makes sense. So then today's lesson, we're going to be adding on to that, but instead of multiplication, we are going to be dividing. So I'll come back to that in here in just a second. All right. So for our two properties of dividing exponents, we have the quotient of powers. Remember, we had the product of powers before. For all integers, for all bases, m and n, for all exponents, m and n, and any non-zero number a, so our base is a, if you have a to an exponent divided by a to an exponent, you're going to subtract the exponents. Right? You're going to subtract them. So let me show you what that means visually. I'm somebody who has to understand the why or the how behind stuff. You can't just tell me a rule and I memorize it. So I'm trying to relay that. Okay, so a to the 6th divided by a squared. That's really saying, I'm going to write out a 6 times. 1, 2, 3, 4, 5, 6. Divided by a squared. 1, 2. Right? This is the same thing as this. We're dividing, all right? And then whenever you have a fraction or when you're dividing, you can cancel out when you have numbers that are the same. So a divided by a just cancels out, right? So these two cancel each other out. A divided by a, these two cancel each other out. So now I've canceled out the entire bottom, right? So what do I have left on top? 1, 2, 3, 4 a's, or a to the 4th power. Okay, so basically I took all of the a's I had on top and I subtracted all the a's I have on bottom. So I had 6 a's on top, right? 1, 2, 3, 4, yeah. 6 a's on top and I subtracted the 2 on the bottom. 6 minus 2 is 4. So when we multiply bases, you add exponents. When you divide bases, you subtract exponents. See the difference here and here, right? Multiply bases, add the exponents, divide bases, subtract exponents. They're literally opposites. Everything else about them is the same, just the operation is opposite. Okay, so let's look at a few of those, or an example with that. Oh, actually, before we touch on that, one more thing real quick. Whenever you have a fraction in parentheses and you've got an exponent here, that exponent gets distributed to the top of the fraction and to the bottom. So this is equal to a squared over b squared. And we can't reduce anything here because the bases are different. They're not like terms. So you're done at that point. So this 2 gets put in the top and in the bottom. All right, so let's look at some examples here. I'm gonna just skip these examples and jump right down here into the practice problems. Hopefully you don't mind. Okay, so I have 5 to the 5th power divided by 5 squared, right? If we were gonna write this out, which I'm not for every problem, but just as a visual here, 5 to the 5th power means 5 times 5 times 5 times 5 times 5, 5 times, divided by 5 squared, 5 times 5, right? So these 5s cancel each other out. These 5s cancel each other out. And I'm left with just 5 times 5 times 5, right? Or 5 to the 3rd power. Now, this is correct, but we're not done. If we had a variable, we would leave it here, but we don't have a variable. 5 to the 3rd power, we can figure that out. 5 times 5 is 25. 25 times 5 is 125. So 5 to the 3rd power equals 125. Make sure you simplify that all the way. Okay, next problem. We've got m to the 6th power divided by m to the 4th power. So our shortcut is when you divide bases, you subtract exponents, top minus bottom. So 6 minus 4, which is m squared. Done. And we don't have a base here, it's just a variable. We can't simplify anything anymore, so we're done. Okay, number 3. Now they're gonna start getting a little more complex, and that's gonna happen. They're gonna get, by the bottom of this page, they're gonna get a lot more complex. Okay, so in situations like this, separate it in your brain, right? Don't think of it as one big thing that looks confusing. Think of it as p to the 5th over p squared times, because everything on the top is being multiplied, everything on the bottom is being multiplied, n to the 4th over n. We just want to line up like terms. This is the same thing as this. I just pulled these apart, right? I multiplied here, I'm multiplying here. It's all the same thing. Okay, so now I can look at this and simplify. So p to the 5th divided by p squared, my base is p, and 5 minus 2 is 3, times n to the 4th divided by n, so my base is n, and 4 minus 1 is 3. So this is my answer here. So you look at this is your answer, right? How would you ever get to this, right? We just follow those rules. Find your like terms, your bases that are the same, and then subtract exponents if you're dividing. All right, number 4, a squared divided by a. That's a 2 minus 1. Remember, when it doesn't have an exponent, it's really a 1. And we're dividing bases, so we subtract exponents. So we get a to the 1st power, which is just a. Whenever you have a 1 exponent, you don't have to write it. Okay, next one here. So we've got x to the 5th, y to the 3rd, divided by x to the 5th, y squared. So we're just going to look at it term by term. So I've got x to the 5th divided by x to the 5th. My base is 5, and I'm going to subtract top exponent minus the bottom exponent, okay, times my base is y, and I'm going to do top minus bottom, 3 minus 2. Oops. Okay, x to the 5 minus 5. 5 minus 5 is 0, so I get x to the 0 power times 3 minus 2 is 1, y to the 1st power. And the last thing that I want you to know, and I believe we're going to talk about it in the next video, is that whenever you have a base raised to the 0 exponent, the answer is always 1. So you could have 57 raised to the 0 power, the answer is 1. You could have 248 raised to the 0 power, the answer is 1. When you have a number raised to the 1st power, the answer is that number, right? 12 raised to the 1st power is 12. 12 raised to the 0 power is 1. So this is going to become 1 times, and this is just y. So my answer here is just y. Another way you can think of it is, this is x to the 5th, this is x to the 5th. They just cancel each other out. And we're left with y to the 3rd divided by y squared, which is just y. Number 6. I want to line up my numbers here. So I'm going to separate this into -2 over 14 times y to the 7th over y to the 5th. -2 divided by 14 simplifies to -1 over 7. And then y to the 7th divided by y to the 5th, 7 minus 5 is 2. So I get y squared. So that's my answer here, -1/7 y squared. You can always pause the video and go back if I'm going too fast. Oops. All right, number 7. I have x times y to the 6th over y to the 4th times x. Now, I want to line up my like terms or my like factors. So I'm going to line this x up on top here with this x on the bottom. I'm just flip-flopping the order that these are being multiplied in. So x times y to the 6th divided by x times y to the fourth. Right? And then I separate out the x's. So times y to the sixth over y to the fourth. Okay? X divided by x is just 1, so that goes away. And y to the sixth divided by y to the fourth, 6 minus 4 equals 2. So I get y squared. That's my answer. Okay, so even though they're not lined up here, remember when you multiply, commutative property says it doesn't matter what order you multiply in. Just like when you add, it doesn't matter what order you add in. You get the same answer at the end no matter what. Same thing with multiplication. So if we flip these two terms, we put the x in front, and then we line up our x's and line up our y's, we get this. Number 8. All right, so here I've got to distribute this 3 to all 3 factors in the top and to the factor on the bottom, right? So I'm going to write this as on the top. I'm going to do a different color. This is 2a squared b to the third over a to the third. So I separated that into the top and the bottom. Now that I separate it to the top and the bottom, now I have to distribute that 3 to each of these 3 factors. So 2 to the third times a squared to the third. Oh, my pen is dying. Times b to the third. That goes on top, and then on the bottom, I still have a to the third. Right? So I'm still simplifying here. They don't give you much room. I should have given you more room to simplify. 2 to the third means 2 times 2 times 2. That's 8. A squared to the third. Remember, when I have an exponent raised to another exponent, I multiply. 2 times 3 is 6. So this is a to the 6th power. If it was a squared times a to the third, I would add the 2 and the 3, but that's not what it is here. Go back and review your properties. And then times b to the third. All over a to the third. So here the only thing that lines up are the a's. So b to the third stays b to the third, 8 stays 8, but a to the 6th divided by a to the third, I'm going to subtract 6 minus 3. Right, so I'm really going to have 8a to the 6 minus 3 power times b to the third. And 6 minus 3 is, of course, 3. So my answer is a to the 8 times a to the third times b to the third. Just keep simplifying, don't stop. Because this up here looks way different than this down here. But we did have to go through all those properties. I'm going to skip number 11 here so we don't run into the same work. All right, number 9. Man, I'm running out of room. Let me try to do it on here. Plus, it's really tiny, so it's hard to read. Okay, so I have 4p to the fourth, r to the fourth, raised to the third power. So first thing I'm going to do is distribute this 3 to everything on top and to everything on bottom. So I'm going to have 4p to the fourth, r to the fourth, all to the third, over 3p squared r squared to the third. So I distributed this 3 to the top and to the bottom here. Now I can simplify more. So now I'm going to distribute this 3 to all 3 factors in the top. So it's going to be 4 to the third times p to the fourth to the third times r to the fourth to the third. Right? All over. And do the same thing on the bottom. 3 to the third times p squared to the third times r squared to the third. Okay, so now we're looking at this. Now we're just going to keep simplifying, right? Let me move this out of the way for a second. Okay, so now I can simplify 4 to the third means 4 times 4 times 4. 16 times 4, I think it's 64. Yep, 64. And then p to the fourth to the third, remember I multiply these numbers together. So 4 times 3 is 12. So I've got p to the 12th. And then r to the fourth to the third, I multiply these together. 4 times 3 is 12. So I get r to the 12th. Okay, so there's the top. Then I have to simplify the bottom. 3 to the third. 3 times 3 times 3 is 27. P squared to the third, I multiply these together. 2 times 3 is 6. So p to the 6th. And then r squared to the third, 2 times 3 is 6. So I get r to the 6th. So moving right along, now I'm here. Now I'm going to line up all of my like terms. So I'm going to line up the plain numbers. I'm going to line up the p's. And I'm going to line up the r's. I'm going to think of them as 3 separate things that I'm multiplying together. All right, 64 divided by 27. Can I divide by 3? Can I divide by 2? Can I divide by 9? Not really. I think it's going to stay 64 over 27. 64 over 27 times p to the 12th divided by p to the 6th. 12 minus 6 is 6. And then with r, 12 minus 6 is 6. So p to the 6th, r to the 6th, right? So we've got this fraction times p to the 6, r 6. So you can either leave it out like this or all of these numbers, because remember these are each over 1. So these all float to the top of the fraction. So you could write it like 64 P6 R6 all over 27. You could write it that way as well. That would be correct. Hopefully that's making sense. All right. So 4, 9, what did we just say it was? 64 P6 R6 all over 27. And then since 12's right there, we'll do 12. Okay, now I want to rewrite this to line up my like terms. Okay, so I've got R and T on top. I've got NRT on the bottom, so I'm going to flip-flop this N and this R. So I'm going to write R7, N7, T2 over R to the third times N to the third. I just flip-flopped them, and then T squared at the end. And I automatically can see that T squared and T squared cancel each other out. They're exactly the same, right? So then all I've got left are R's and N's. Now 7 and 3 are not the same. They're not going to cancel each other out. So I'm left with a base of R, and since they're being divided, I'm going to subtract the exponents. And then times a base of N, and since it's being divided, I'm going to subtract exponents. So that's R to the 4th times N to the 4th. That's our answer. Good? Okay, and let's do one more, number 10 here. I've got some room, so I'll try and solve it all on this paper. First thing I want to do is distribute this 4 to the top and to the bottom. So I'm going to write the top 2r to the 5th, w to the 3rd to the 4th, r4, w3 to the 4th. And then I can distribute that 4 to each factor. So that's going to be 2 to the 4th times r to the 5th to the 4th times w to the 3rd to the 4th all over r to the 4th to the 4th times w to the 3rd to the 4th. Okay, you still with me, following me? I might have to use another sheet of paper here. All right, so 2 to the 4th means 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this becomes 16. R to the 5th raised to the 4th. I multiply 5 times 4 and I get 20. W to the 3rd to the 4th. Multiply that and I get 12. And then on the bottom, 4 times 4 is 16, so r to the 16th. 3 times 4 is 12, so w to the 12th. So I'm down here now at this point, but I still have to simplify. Excuse me, I can't... Ooh, caught in my throat. I can't simplify this 16 because there's no number to simplify it with, so it stays 16. For the base of r to the 20th divided by r to the 16th, I subtract 20 minus 16. So I'm going to have that 16 in front. And then my base of r, 20 minus 16 is 4. And then w to the 12th divided by w to the 12th, they're exactly the same. 12 minus 12 is 0, and w to the 0 power is just 1. But I'm not going to write a times 1 here. I'm not saying it's w to the first power. I'm saying the entire thing is the number 1. Anytime you have a variable or a base raised to the 0 power, the entire answer is always 1. So here's our final answer for this problem. Right? It looks way complicated, and then our answer is just boop, simple. Okay, stay tuned for video number 2. We're going to keep working with some more properties of exponents and division.